So now I'm going to show you how to carry out a paired samples or related samples t-test in SPSS. And I'm working with a file where I was testing the effect of different manipulations on attitudes towards helmet use in people who ride horses. And we'll have seen this file at other times, and you'll use it later, but you won't use it for paired sample t-tests. So here I'm going to look at how attitudes towards helmet use change it from pre-test to post-test without considering any of the manipulations, just for sake of showing you how. So to run a paired samples t-test, you can analyze, compare means, and then down to paired samples t-test. Okay. And you can see here we have pair. We can actually do as many pairs as we want. You can enter the pre and post either way. I generally like to put the first variable, the one that I hypothesize is going to be greater, but it doesn't really matter. So here we have post attitudes. That's post attitudes towards helmet use. And here we have attitudes towards helmet use pre, okay? By default, it's going to give you effect sizes, okay? You have options that you don't need to worry about because we're just doing one pair, right? And then we just hit OK. Very simple. And here is the output. First, SPSS. Let me make this bigger and use my pen to show you things. One moment. All right. Okay, so as usual, the app stream is glitchy, but I'm using this for those of you who do. Okay, so let me get my pen. So first, SPSS gives you just the descriptive statistics. It gives you N, or the sample size, which because there's paired samples is the same for both, 1,185. It gives you the mean for post-test attitudes towards helmet use. And here, higher scores mean stronger approval of using helmets while riding horses. And we have the pre-test scores, which are much, much lower just by eyeballing, right? Now, the standard deviation is much greater in the post-test than in the pre-test, okay? This, in fact, is because there was a manipulation here, but we're not going to worry about that right now. All right. The next table is just the correlation between the pre and post test, okay? So it gives you just that's your Pearson's R, but for paired samples, okay, it's 0.58, so it's strong, as would be expected when it's the same people, repeat test, right? Okay, and finally, we get the thing we're really interested in right here. So this is the pair one, and this is just called pair one because you could have as many pairs as you want, right? Well, there's probably a finish, but right, this is for the mean difference. The mean difference between time one and time two was 4.12. You'll notice that that is just subtracting 3.64 from 7.76, right? So 4.12, that's the standard deviation of the difference. And here we have the 95% confidence interval for the difference between the means, right? We have the t-value, which is 62.20, rounding to 2 decimal points. And for both one-sided and two-sided p-tests, we get p is less than 0.001. Okay, p cannot equal 0 ever. So when SPSS gives you 3 zeros, you just write p is less than 0.001. All right. So how would you describe this? You'd say attitudes towards helmet use were much more positive in the post-test than in the pre-test. Okay. And then you just, the notation would be T, parentheses, degrees of freedom. So it's N minus 1 for a paired sample test, right? Equals the t-value, 62.20, comma, p less than 0.001. That's a less than right there. And then we might want the effect size. So we can put comma, D equals, and we have right here, down here in the final table, Cohen's D, and we're going to use that. D equals 1.81, which is a very strong effect size, right? All right, so that's how you would run paired sample t-tests in SPSS.